afternoon, everyone. Welcome to yet another lecture of the web-based decision support system course, which is intended for both business decision makers, practitioners and academicians. And we have been going through major aspects of it, and we have as a quick overview, we have studied that the DSS has 4 major components, and we are now going through slightly in depth into one of the major component, the database management system, DBMS, and proceeding with that. So, we have already seen major aspects of it, which includes the what is a ER diagram, what is an entity, what is a relationship, how to translate from user specification to ER diagram, etc. So, without further delay, we will get into today's topic, which is the translation of ER diagram, entity relationship diagram, to DB, database. Okay. So, let us first start with the major definitions. Okay. So, this is also a what we call as a recap plus additional. Okay. So, we have yesterday discussed something called as SQL, okay, what we call as structured query language, okay. And we had seen what it is. Actually, we talked about what is a query language and high level stuff, etc. So, what we are telling today now is it's by definition it's like it's a standardized. So, so standardized means it will work on standardized query language. We will talk about what is standardized query language for getting information, from a relational database. Okay. So, it is a standardized query language. SQL is a standardized query language, okay. But the idea is whatever be the RDMS, the relational database management system, okay, RDBMS, okay, whatever be the relational database management system, whether it is MySQL, Oracle, Microsoft SQL Server, it does not matter. It can get information from the relational database. Okay. So, that is the first thing. Then we also talk about, we had already talked about what is a relational database, but let us recap this again quickly. Okay. What is a relational database? So, we says that it is a database that stores data in the form of relational tables, okay, as opposed to flat files. Okay. So, when we say relational database, it is a database that stores data in the form of relational tables, tables that are related to each other, okay, or having data that are related to each other, as against flat files. We are not storing it them as files. Okay. Then the last one we would like to talk about is database management system. Okay, or DBMS, what we call earlier. Okay. And we had couple ways to look into it, right. So, one simple way to look it is a system that manages relational databases. Okay. It can also be little bit elaborate. This definition can be a collection of programs, computer programs, collection of programs that enable the storage, modification and extraction of information from a database. Okay. So, it is a collection of computer programs that enable the storage, modification and extraction. the main functions, okay, of information from a database. So, that is also another definition of the DBMS. Okay. So, the DBMS for this course is MySQL MariaDB. Okay. Both are the pretty much the same. MariaDB is an open source portal, MySQL is the paid version out of Oracle. Now, MySQL, which is an open source thing, it is now owned by Oracle. Okay. So, what is MySQL and MariaDB? Okay. So, it is the main characteristics I am going to write. It is an open source. Okay. Open source means it is free, freely available, open source. It is an enterprise level. It is an enterprise level. So, you can use it for banks and other critical operations, etc. It is a multi-threaded, okay, means multiple instances can be run at the same time. These three features, okay, relational database management system, okay. So, it is an RDBMS, okay. That is an open source enterprise level and multi-threaded relational database management system, okay, that can store and retrieve data using the structured query language. Okay. SQL. Okay. So, what it does is it is an open source enterprise level multi-threaded RDBMS that can store and retrieve data using the SQL. Okay. So, it is predominantly dependent upon the SQL. So, earlier MySQL there was only one, then it became two. Okay. There is an Oracle version and a MariaDB, it is a two fork. The MariaDB is the open source version now. Okay. This is the open source version. I think the Oracle version of the MySQL now paid, I am not sure about that, but you can figure it out. So, now in the database, the MySQL MariaDB, the building block, the lowest possible thing is a what you call as a cell. Okay. So, how do we define a cell? Cell which is a single, okay, or scalar value. So, if I have a says 1, 2, 3, 4, 1, 3, 5, some number is being stored there, and this is one single set of a value, then we can call this as a scalar or a single cell. Okay. Some people call it as a cell, some people call it as a scalar value, some people call it as a single value. Okay. Now, the next one is what we call as a rows. Okay. So, what is a row? Okay. It is a group of scalar values representing a single instance of an object or event. Okay. It's complicated definition, but it is very easy to understand. If you think about this, cell usually some attribute of an entity. Okay. So, some attribute of the entity usually gets stored in the form of a cell. Okay. Whereas, in a row what happens is, so an example of a row is something like this. Okay. Yeah. Some 1, 2, 3, 4, 1, 3, 5, okay, and you have 1, 1, 3, 9, 4, 6, 2, 4, 1 or something like this, and then there is something called as a letter 23 July 2022, something like this. So, assume that this is something that is a register that we take care of a place. So, this is a one instance. Okay. So, if this table contains all the there is another row that may be something like this here later, which says 16220031 84 39 23 231 something like this, and you can say that as a gift packet, okay, 29 July 2022. This is another instance. Okay. These are instances of an object, okay, or an event. A lot of the time this could be an instance of a entity also. Okay. So, a lot of the time entities can be, these are instances of entities. Okay. All right. So, now then comes what we call as the tables. Okay. So, what is a table? We define a table as a series of row describing separate objects or events. Okay. So, let us say you have a ER entity diagram, you have something called a student, okay, and you have something like student ID, okay, and you have first name, last name, date of birth. Let us say if this is what you are doing. Okay. So, then one of the way to think about it is, okay, this can be translated to a table like this. Okay. Stuff like this, where student ID, first name, last name, date of birth. Okay. So, you can say 23231 Ram Charan 11/20/20 and 64261, okay, Geeta Rani 38/20/2006, etc. So, this table, this entire table, okay, is a representation of student. Okay. So, the entity typically, okay, so table you can think about it as a entity, equivalent to an entity, right, and each row of the table is an instance of entity. Okay. Sometimes it is also known as tuple in some ways. So, same way what we saw previous in that is that the same thing, we have an ID where these numbers are written 1 2 3 4 1 2 3 5 like this, these are consecutive IDs, okay, and there is some docket ID, some other IDs going on. Okay. And this docket ID is one of the labels, says letter is a November 18 2020, there is another letter July 23 2020, then there is a parcel to Korea. So, it might be a register. So, this could be an entity which is like outgoing register or something like this, and each one of them is a entry in the particular register. So, it is an instance of the register. Okay. So, that is what a table is typically all about in this regard, but also remember. Okay. So, each one of these, the student ID, you can see the first name, okay, last name, date of birth, each one of them. So, the attributes usually translates to what we call as columns in a table. Okay. So, that is how the attributes are considered most of the time, and each one of them, let us say for example, we take this Charan, this is what we call as a cell, okay, and this is what we call as a row. Okay. All right. So, I hope now you guys have a mapping of how does an entity translates to what you call as a table and what are the different aspects of it. Then databases. So, then what is databases? Okay. Now, we have seen what is a cell, we have seen what is a row, we have seen what is a table, and we have seen the connection between the cell, the columns, the rows, entities, etc., attributes, etc. So, then what is a database? Okay. So, the definition is that database in simply it is a collection of related tables. Okay. The critical word is related tables. Okay. So, tables containing data that have some relation, okay, or you can identify some relation as part of this. Okay. And what does this related tables do? They describe various facets of a group of objects or events. Okay. So, that describe various aspects of it. So, here is an example. You have an object, this is a one database, it is an object database, okay, or object table, this is the object table which has 3 attributes. So, you can draw this as like this, okay, object entity, okay, you have ID, okay, you have docket ID and you have label. Okay. So, this entity object gets translated to a table, right. So, then there is another one, another entity called ceilings, okay, which has something called docket ID and there is something called call ID. Okay. So, let us assume docket ID is the unique identifier. So, then that is connected here. Now, you can see that between these two docket IDs you can connect, you can relate these two databases, relate using docket ID. Okay. So, now the other one calls is basically then, okay, whatever that entity is, you have ID, unique identifier, there is name, okay, URL and abstract. Okay. So, that gets translated to another table and this ID is related to this ID. Okay. So, you can see that things can be connected or related using another relation. Okay. So, the entities gets translated to table. So, entities translated to tables, okay, attributes to columns. Okay. This is another way to think about it, right, and then relationships into the form of keys. We will see in an example. Okay. So, now let us talk about what are the major type of relations. Okay. The first relation is called one to one. We have also seen what this is also related to what we call as the cardinality of relations, cardinality of relations. Okay. We have seen one to one yesterday, 1 comma n and n comma m, right. So, we will be looking into trying to figure these out pretty much all the 3. Okay. So, this one what we are saying is 1 to 1, that means one record. Okay. So, this is 1 to 1, 1 comma 1. Okay. That means one record or row in table 1 is exactly related to some other row or record in table 2. Okay. You can also rewrite this. Okay. Another way of saying this is one tuple in relation 1 is exactly related to some other tuple in relation 2. Okay. So, when you hear the word tuple, okay, tuple literally means a row. Okay. Tuple is equivalent to a row, okay, or an instance, okay, which is equivalent to an instance of an entity, right. And then entity equivalent to a table, which is equivalent to also known as a relation. So, these are the terms that you see very popular in the DBMS. Now comes the second one to many. Okay. This is the scenario what we call it is in the 1 comma n. Okay. So, how do we say this? Let us say this way: one record row tuple in table 1 or relation 1, okay, is related to more than one record slash row slash tuple in table 2 or relation 2. Okay. So, we will see multiple example of this, but this is the 1 comma n scenario. One record, this is one record, or you can think about it as one row or one tuple, whatever you want to call it, okay, is related to multiple records in another table, okay, are somehow related. So, if you take an example of here as a is a student, and these are the courses, okay, course 1, course 2 and course 3. So, the this particular student is student X is taking course 1, 2 and 3. So, 3 courses. So, that student 1 is connected or related to these 3 courses. Okay. Now, let us talk to what you call as many to many. Okay. So, this relation is many to many, where we call as M n in the cardinality thing, right. So, the one way to write about this is in the following the previous argument. Okay. We can write it as a record tuple row in a table or relation is related to many other records, tuples, rows in another table or relation and vice versa. Okay. And so, what happens is it is, so for example, if you take, okay, record, this particular record, it is connected to this record and this record, okay, but this record is also connected to another record in this table. We can see that there is 2 connections possible as part of this. So, the same record can be connected to different records in the table. So, both sides. Okay. So, it is a many to many. Okay. So, M to N relationship. Okay. It is more complicated to manage, but we can manage this. So, let us look in this example of the what you call as the company database, the ER diagram. Okay. We call it as, this is adapted from Elmasri and Navate. I have mentioned in the earlier class also. So, let us see that this is the ER diagram, where we have an entity, an employee entity, a department entity, project entity, dependent, which is a weak entity, right. So, in this case we have entities as the employee is one entity, then department is another entity, and project is a third entity. Then we had a weak entity in this, which is the dependent. Okay. And relationships was managers dependent of controls, works for, etc., which are all written in these ones. Okay. And there are so many attributes. So, this was the broader idea. Okay. So, now with this, our fundamental attempt at this point is to translate this into what we call as a schema, okay, or schema diagram. We have already seen the previous class. It is an intermediate step between translation from ER diagram to actual database table design. Okay. So, it is an intermediary step. So, one of the way to look into is, if you look into this, the one of the thing is employee. So, let us take the how do we draw the schema diagram of the employee. So, the schema diagram of the employee will most probably be something like this. Okay. I am just going to draw this slightly big. This is the employee, okay, and the attributes of this. Okay. So, it is the SSN, social security number, which is a key attribute, is written there. Then the birth date, first name, middle name, last name, right. So, you have first name, middle initial, last name, okay. So, that is already there. Then sex, birth date, okay. And then you have what you call as address and salary. So, okay, we will call it as apartment, I am just apartment, street, city, state, pin code or zip code, whatever you want to call it, right. And then what we have is the salary. Okay. So, these whole thing what we just drew here is what we call as the schema of the table. Okay. So, now let us do one more. Let us take the department or project as another one. Okay. Let us take the next entity as project. So, project has a name and a number and a location, right. So, we will draw something like this. It will be, okay, project has a number, it has a name, okay, and a location, okay, something like this. Okay. So, if you look into this, then we know that the name and the number are underlined. So, that means they are key attributes. So, then we are also underline the name and number kind of a thing. Okay. So, then we can do the next one is the department. Department has a name, number and multi-valued locations, okay, number of employees, that is another one. So, you can do another one is, okay, department, etc. Okay. So, it is number, department number and department name and locations. Okay. But these locations are multi-valued attributes, but these are same way. So, this representation of the translation of the ER diagram what we just drew here to what we call as the schema or basically the design of the table is what we call as the schema diagram. So, hopefully, this makes sense to you guys. Okay. So, now there is one thing that you can think about it is there is an employee that works for a department, right, whereas a department can have multiple employees, correct. So, one way to think about it is there is a department and department has a number, and so if you think about this employee table, okay, let us call this as the department number. Okay. So, now what happens is this department number is something which department the employee is working for, that department number is linked to this department number. Okay. So, now you can see this relationship what we see here, the employee works for the department is pretty much created by putting the department number in the employee table. Okay. So, this is the SSN is the unique key, each employee, each row will have the unique value. So, this kind of thing is called as a primary key, whereas the department for which the employee is working for, which is a primary key of another table, This is sometimes you call as a foreign key. We will explain what a foreign key in a minute now, but this in a schema it also allows you, or the schema diagram translates the ER diagram to DB table design while identifying foreign keys to map the relationship. The reason why we use a schema diagram is to convert the diagram, the entity concept, whatever we drew in this, translate those into a DB table design. You want to design the database table, while you want to also identify the foreign keys. Okay. How do you map? How do you embed these relationship, works for, managers, controls, works on, etc. these relationships into different tables by linking various columns. That is what the main advantage of creating a schema diagram. This is an intermediary translation part. Okay. Now, that I mentioned foreign keys here. So, let us now talk about what is foreign keys in a second. Okay. So, and foreign keys is an important concept, and again we are not going to go into too much of details, but the fundamental aspect is, okay, transform each one to one or one to many, okay, relationships as a foreign key. Okay. The main idea here is that use either one to one or one to many relationship. You translate them or you transform them, each one of them, into a foreign key. So, what is a one to one relationship? This is a one to one relationship. Exactly one record in table 1 is related to another record in table 2. One to many is one record or one tuple is related to many other records in table 2. Okay. Table 1, one record is related to many records in table 2. So, in both cases, the one to one or one to many, we map the relationship as a foreign key. Okay. So, another way to think about it is, foreign key is a reference in the child, okay, or the many table, child table, to the primary key of the parent or the one table. Okay. So, what we are saying is, if you think about it, this table is what we call as the parent, this is the child, and same thing, this is the parent and this is the child. Okay. So, if you think in that way, what we are talking here is, foreign key is the reference in the child in the many table to that of the primary key of the parent, the one table, the table from which it comes in. So, now let us take a look into this department and employee. Okay. One department has multiple employees, okay, or employee works for one department, or a department has many employees. So, let us draw that as an example. Okay. So, let us take this department, okay, has employee, department has, so department 1 n, okay, that is how we drew here. So, each employee will work for exactly one department, whereas one department will have multiple employees, right. So, if you want to really draw the min max here, the employee going this way, okay, employee will work for minimum of one department, maximum of one department. A department will have minimum of one employee, maximum of n employees. So, that is another way to draw it. Okay. So, that is what we have. So, then when you have a relationship like this, how do you create or how do you translate that to tables? Okay. So, I am going to write two queries here. Okay. So, the first one is I am going to create a table. Okay. My first step is create the department table. Okay. And then the second part is the create the employee table. Okay. So, I will write the SQL command. So, let us write the SQL for this for the time being. Create table department. Okay. So, I am going to say is as department underscore number. Okay. As I am going to say is as int. Okay. Name is varchar variable character 50. Okay. Varchar stands for variable character. Okay. Variable character, and that is part of the MySQL. And then I am saying that primary key is department underscore number. Okay. So, this query will create a table with two columns. Okay. So, I have what you call as a table like this. If you think about it, department underscore number and name. Okay. So, I may have department number 1 HR, department number 2 accounts, department number 3 marketing, etc. Right. So, each one of the row is an example of a particular department. Right. So, this department number 1, 2, 3, these are, this is the primary key. Okay. So, one department, each department have many employees. So, in this case the one table or the primary table or the parent table will become the department. Here is the parent table. Now, comes the child table in this, because a department can have many employees. So, I am going to write the SQL for creating the employee, that is create table employee, okay, with, okay, I am saying that emp number, employee number int, I am just putting as int stands for integer. Okay. So, then I am going to say as department number underscore number as also as int. Okay. Name varchar 100, okay, as the name of the employee in this case, right. Then the what you call as address, okay, for the time being, address varchar 250, something like this. Okay. Then I will say primary key, I will say it as employee number, okay, that is a primary key. Okay. And then I also have something called foreign, foreign key, okay, where I will say it as department number, okay, references department. Okay. So, now this command tells the DBMS that now I have another table, that is the second table, where I have, okay, I have a, I hope I am able to draw this properly, emp number, the employee number, then there is something called department number, then there is a name and address. Okay. All right. So, I have employee number as 101, then there is an employee number as 102, employee number 103, etc. Okay. And I have Ram, Sita, Geeta, like this. and I have department number as 2, 1 and 1. Okay. Address is some Ayodhya, something like that. Sita is New Delhi, Geeta is Jaipur, etc. Right. So, I am just typing things. Okay. So, you can see that this department 1 1, which means these Sita and Geeta belongs to the department number 1, which is the HR. Okay. So, this employee number is the primary key, okay, of the child table. Okay. This is the child table, whereas the department number, which is the primary key of this, is connected as the foreign key. Okay. So, the idea is both the parent and the child, when especially when it comes to what you call as the one to one or one to many relationship, we create using the foreign key, we connect these tables using the foreign key. Okay. So, I have an example. So, here is a department as department number 1, 2, 3. So, this is the department is the relationship or department table. I have department number and department name as we wrote earlier, because this is the query that we created, department name and number. Okay. And then we have employee, okay, and employee number, department number. Okay. So, we have Geeta Rani, Ajay Patel, Ram Charan, Ben Smith, Salman Khan, Judy Hepner, that's different thing. So, you can see that from here employee number 1, Geeta Rani, works for department number 2. So, which is department number 2? You go to department table 1, find the primary key, which is department number 2, says human resources. So, Geeta Rani works for human resources. Okay. So, by instead of typing the department name all here, this primary key can be put in here, so that we can cross reference each department. Okay. All right. So, now what are one of the advantages of doing this? So, let us look into this quickly. Accounting has only one employee, because this is the Ben Smith, one employee of accounting. Okay. This connected to each other. Then human resource has 2 employees. How do you know there are 2 employees? Because human resource department is number 2. So, you have 2 and 2. So, there are 2 employees like this, and IT has 3 employees. All the 3 in the department number is related to IT. Okay. Instead of this, let us think about a scenario where you had something like this. Okay. Okay. Employee number, department name and employee name, assume it this way, and we had something like this. Okay, like this is going on. Our employee number 1, okay, this is human resources. Okay, employee name is Geeta Rani. Employee number 2 is IT, Ajay Patel. Employee number 3 is 2 is human resources. Okay, Ram Charan. Okay, employee number 4 is accounting. Okay, Ben Smith. Let us just take one more employee. Employee number 5 is IT, Salman Khan. Okay. So, assume that somebody decided to change the name of IT department, okay, to information systems. So, assume IT changed to information systems. Okay. You change the name of it to information systems. In this design, you only need to change this here. Okay. One change. Okay. Only one place to change. Okay. Just change this IT. In this case, you will have to change many places. Wherever you type IT, you have to go there and change. Okay. So, what happens is this violates the principle of DBMS, because you want to eliminate redundancy. These kind of multiple changes, okay, redundant changes, or what you call as update anomaly. We will study about this later. Okay. But that is one of the other reasons why foreign keys are important, rather than typing all this information in a database. Okay. Now, let us take the next one, what we call as the many to many tables. Okay. So, the many to many tables is in this case the primary rule or the fundamental guiding principle is transform each many to many relationship as a table. Okay. Create a new table. Okay. Each many to many relationship or is now translated to a table. Okay. So, now how is this happen? So, that is the relationship table, you are creating a new table to capture the relationship. The relationship table will contain, the guideline will contain the foreign key to the related entities okay, as well as any relationship attributes. Okay. So, the relationship table, the new table that you will create will contain the foreign key or foreign keys, okay, foreign keys to both of the related entities. So, both the foreign keys from both related table, because remember many to many is this, okay, it is related to both tables. Okay. So, in that regard we are creating a foreign keys from both table will come into this picture. Okay. And also that any of the relationship attributes, what is the relationship attribute? This is a relationship attribute. Okay. Relationship attribute. Okay. That is the case. Let us take an example of the project and employee. Okay. Let us take this as an example. The employee works for a project, okay, and let us take a start date of is something that you need to capture. Okay. So, let us create a relationship here. Okay. So, we have project, okay, and there is project has employee, and the start date of the employee on that particular project is a aspect, okay, of the relationship. Okay. That is the case, then what we can do is we can write a SQL command for this. Let us create this SQL command for creating this relationship table. Okay. So, we write it as create table. Okay. I am going to name it as project has emp. Okay. So, I am saying that the project has employees, it is a new relationship table that I am creating at this point. Okay. And you have something called project number as the int for the time being, comma. Then I have employee number, that is also integer. Okay. Then start date as date. Okay. Then I have is primary key. Okay. I have project number, comma, employee number. Okay. So, I have two of them, two of the rows together, now identifying the primary key. So, these kind of primary keys are also known as composite primary key. Okay. Two of them are there, right. And then I am saying a foreign key, okay, project number is a foreign key, references project, that is the references the project table, and I am also going to say foreign key employee number references, okay, employee, okay, semicolon. So, what we are saying is the primary key in this regard is, if I create a table, I will have if I create a schema table, I will have project number, I have another one called as emp number, and then I have start date. Okay. But both of these together, these two attributes together will be my primary key, okay, for this project, and the project number will refer to the, it will refer to the project table, okay, it will refer to this one, whereas the employee number will refer to the employee table. Okay. That will be the primary key of the employee table, right. So, that is how the relationship gets mapped out in this regard. Okay. So, if that is the case, then let us look at an example quickly. So, you have a, as I said earlier, the project table. Okay. Project table has what we call as the project number. Project number is the primary key for this one. Each project is uniquely identified by a number in this regard. And then I have what I call as an employee table, right. As we were talking earlier, we have a project table. So, here is your project and you have your employee, okay, and this table is your project has employee table. Okay. So, this is a new table that captures the relationship, the project has employee. So, there is a project table and here is the employee table. So, there are 3 projects, employee audit, budget and intranet, and the employee number is 1, 2, 3, 4, 5, 6. So, from there we create a new this stuff, that is table, that is called as project has employees. Okay. So, the project number is now, okay, this is the primary key here for this table, okay, and but this is a foreign key relationship. The employee number, this is a primary key here for the employee table, okay, but the employee, this one is a foreign key relationship. Both of these put together as the primary key for this table. Okay. So, what do you mean when you say that for project number 1, which is employee audit, employee number 4 is Ben Smith, started working on it from the date is 6/4/1999, right. So, if you look into this, we take the details, then we can say that the employee audit has one employee, that is Ben Smith. Okay. We are able to connect them using this, right. If you take the project number 3, okay, project number 3 is intranet, employee number 6 is working on it. So, 6 is, if you look into this, Judy Hepner. So, you can see intranet project has Judy Hepner, then 3 has 5, employee number 5 is Salman Khan, that is also there. Then project number 3, which is again intranet, has employee number 2 is Ajay Patel. So, all the 3. So, using this approach you can map which employee is working on which project, and the start date information, which is a thing that is connected to your relationship as we shown here, is captured as part of the table in this regard. So, the start date, this is a attribute of the relationship. Okay. So, with this I hope the translation, the concept of primary key, foreign key, etc. are clear with you, and what we will do now is, after this we will move to the next concept of how to, from this table design, one primary key, foreign key, etc. we will talk about what is database normalization, so that the queries and other things can be done efficiently, and after that we will look into some of the major SQL commands, and then where to look for to learn where how can you learn some internet resources to learn MySQL and MySQL, MariaDB, etc. And once that it is completed, then I will give a quick introduction to big data, and then that will pretty much complete my portion of the database aspect for this particular course. But also understand, we are not gone into details of step by step of breaking it down. I am just giving you an overview. These kind of step of how to conceptually design from a user specification, come up with an ER diagram, from the ER diagram to a complete schema, from schema to a table, identify primary key, foreign key, create it, normalize it. All those continuous examples will be taught as part of the advanced component of this course, but this is to give you a fair idea of what is going on. So, thank you for your patient listening, and we will continue the remaining in the next class. Thank you.